Hey guys, my name is Sandeep Patel. I'm the founder of Slotify.ca. In this video, we're gonna learn different way we can access arrays, right? And we will also compute their time and space complexity of each method. Okay, so the first question is how many different ways we can access an array, right? So we know that the arrays are defined by their index, right? They have index that start from 0 until n, and they could have like n different elements, right? In this case, there are two ways you can access array, right? So you can find by value. For example, let's say that you want to find where one is located, right? So how do you find? So you can say, okay, give me the value at index 0. So you can find by index, right? Or you can say, I'm gonna loop through the array elements and then find where one is located and then return, right? So there are basically two ways you can access array elements, right? And what is their time complexity or space complexity for each operation, right? So let's learn that with some code. Alright, so I have some code here. I have two functions, get value by index and get index by value, right? So we're gonna complete the code for each function and then calculate the time and space complexity, right? Okay, so let's try first. So given this function where you have array as an input, right, and then you also have an index, right? So we had to return the value at this index, right? So simply we can say return array at this index, right? Right? But we can also cover the base case. For example, let's say if this is not true, then we return -1, right? If we can't find value, then we can return -1, right? How do we find by value, right? So let's say given that you want to find number 10 in this array element, even though there's no number 10, like there's no element called 10 in this array, right? But let's say we want to find. So how do you do that, right? So with indexes, it's pretty easy. You can access it like this. But when there's no index given, then what you have to do is you have to loop through an entire array. So you start with 0 and you run until array length, and then you go step by step, so one element at the time. And then let's say when you find at that particular index, you find your element, you compare it with the element you're looking for, and at that time you can return index, right? So basically this function returns the index where it finds that particular value. If we don't find any index, then in simple case we will return -1, right? Okay, so let's run this code and see. So what we're trying to find here, when we call get value by index, we want to return what's on the index 0, right? So you can see in this array at index 0 you have 1, right? So this should output 1. And let's say the second function we're calling get index by value, we want to search if there's element with value 10, but because there's no value in this array 10, we're gonna return -1. Alright, we can see it's returning 1 and -1. So let's say we want to find get value by index function. Let's say we want to find number 5. So what is the position of 5? So you can count from 0, index 0, 1, 2, 3, 4. So we're gonna change this to 4, and so this should return 5, right? Because at 4th position we have a value of 5, right? So when you run, it returns the correct value, right? And similarly, let's say in this array we want to find what is the index of 6, right? So the index of 6 is what? 0, 1, 2, 3, 4, 5, right? So let's say we're searching for index of element 6, so that should be 5, right? Because it's a zero based index. Index is always start with 0, right? So in that case it returns 5 5, right? So this is how you can access arrays. Let's focus on time and space complexity for each solution. So in this, if you read about time complex video, if you watch my video on time and space complexity, it's pretty easy to calculate time and space complexity. So for time complexity, what we're looking for is basically when we run this code, how many times this line of code runs, right? So when I execute this function, this line will call only one time. So let's say that this is calling 1 unit of time, right? So this statement runs on 1 unit of time. And because there are no other statement, right, you can say that the complexity of this code is O of 1, right? Similarly, for space complexity, we're looking for variables or returns, right? So there are no variables in this function, right? And there's only one return, and which also returns 1 unit of space, right? So when you calculate the space complexity, you consider unit space, and when you calculate time complexity, you're worried about unit of time, right? So because there's one return, it's not dependent on the input size. We're also getting space complexity O of 1 for this program, right? How about this one? So in this one, we have this input, right? And this array is dependent on that input, right? So why I'm saying this is because the loop starts from 0, right? And where does the loop end? So this loop ends when array size, when I reaches to the array size, right? And what is the array size? We don't know, right? Because we're passing from outside. So this could have 5 elements, this could have 500 element, or maybe 1,000,000 elements. We don't know, right? It can grow dynamically in size, right? So you can say that this loop will run n iteration, right, where n is the array size, right? And everything within that for loop, let's say this statement, it's running 1 unit of time, right? So this statement is multiplied because it's within a for loop. Anything within the for loop will be multiplied and count toward this overall time or space complexity. So in this case, this statement takes 1 unit of time, is multiplied n iteration, so that becomes n unit, right? So in this case, you can say this function has overall complexity of O of n, right? And in big O, we're only concerned about the bigger term, right? This is also O of 1 space, O of 1 time, but we don't care about this because this one is a bigger term, right? This takes O 1 into n, which is On, right? So we're concerned about only this code. We don't care about, if you take out this code, right, then this will run only one time, right? No matter how many times you execute this function. So we're concerned about only this, and when we calculate space complexity, we're concerned about the variables and return, right? So in this case, you can also say this, we're not using any additional auxiliary space like the variables, right? So in this case, you can say it's O1, right? We're only concerned about the variables or call stacks, right? We don't count this return towards space. Alright, I hope you like this video. Stay tuned for my other videos. Thank you.